This is our final presentation for recommender system for Career Village. Our team members are Mingjiao, Wei Huang, Yawen. Let's firstly go to the executive summary for our project. Here I'm gonna introduce three parts of our project. For the background, we give a solution to Career Village, a website that provides underserved youth with access to career advice and guidance to construct a recommender system for professionals answering the questions. Our objective is to help Career Village match questions and professionals in a more accurate way. As for the methodology, we firstly collected and cleaned our raw data from Career Village. Then we generated several different topic groups for all contexts in questions and answering by using LDA. Next, we made predictions. Finally, we evaluate our performance and made recommendations accordingly. Here is the agenda for our presentation. We're gonna introduce top modeling, recommender, and performance, and finally, the future work.
First part is topic modeling. We use the LDA model to help us learn the topic of the original question and answer. The number of topics has great impacts on the topic generation, thus it is essential to decide the number before. According to the scores and the coherence value, we found the number of 4 is suitable. Then we got 4 topics from the original text after text processing. Topic 0 is concentrated on how students wisely pick colleges for career goals. Topic 1 represents how to better perform in the workplace. Topic 2 indicates how to successfully achieve a professional degree in service areas. And topic 3 shows how to obtain a degree in the science like computer science, engineering, and so on. This result also includes the distribution of awards for each topic. Based on this result of topics, we could learn the topic distribution for each question and each professional. We took each question as one document and took the whole previous answers of each professional as document for one professional. Here is one example for questions and professionals. The bar charts here show the topic distribution of 2 examples over the topics we have gotten. It is obvious that those 2 topic distributions are not similar, thus this question should not be assigned to this professional. We will talk more details on the similarity between 2 distributions in the next part.
After we got the topic distributions, the next step was to match the question with a group of professionals who were very likely to answer. There were 2 attempts to match. The first one was matching the questions and professionals only by similarity. The similarity in this project was measured by cross-entropy. If a question and a professional were very similar over the topic distribution, cross-entropy between them would be high. Given the similarities, we ranked the professionals for each question and selected the professionals within the first decile as recommender targets. The recall of recommending by similarity is 1.72%, and the precision is even lower. That indicates the metric we used or the idea that we recommend only by similarity was not so good. Given the performance of the first attempt, we built a predictive model using logistic regression with the hope to improve the performance. The output in this prediction was whether a professional answered a question, and the only features we could generate were the similarity, the frequency of email notification, and the average likes for answers. The number of records in the data was nearly 700 million, which was too large. Inputting this size of data exceeded the capacity of computing, so we randomly selected a small sample for use. The performance of this prediction was even worse, and it predicted no professional would answer any question. But the model could have done better if given more informative features and higher computing capacity. So far, we could only recommend the questions to professionals based on similarity, but more future work could be done to improve this recommender system.
Well, let's go to the future part. There are 2 kinds of the challenges we met. The first one is about data processing. Actually, we could not completely clean out noisy words because of the unrecognized pattern. The other challenge is that data is not sufficient and the computing capacity is limited. The prediction and feature engineering needs future improvements. So we're gonna give several recommendations accordingly. For data processing part, we can use more advanced tools for task cleaning, like considering about NLP. For prediction, we could gather more demographic information, increase computing capacity, and might incorporate neural network and NLP into the modeling and prediction. Thank you.